Next problem is number 14, and 14 is lot sizing problem. We are given holding cost is 80 cents per unit per week, and setup cost is $300. Now we want to look at lot for lot, EOQ, and periodic order quantity. So we'll start with lot for lot. Okay. So lot for lot, we have on hand. Okay, so we start with 100. So 100 is gone, 0. So 250 is the net requirement. So 250 is the planned order receipt, and therefore 250 is the planned order. And then we have 0, 200, 200, 200, and 0, 150, 150, 150, 0, 250, 250, 250, 0, 200, 200, 200, 0, 200, 200, 200, 0, 150, 150, and 150. So this is our lot sizing plan. So now we have to compute the cost. So there are two costs, setup cost and holding cost. So see, number of setups is 1, 2, 3, 4, 5, 6, 7. So setup cost is 7 setups times $300 per setup. So that will be 2100. Now total ending inventory. So carrying cost is based on ending inventory. So that's ending. So this is beginning inventory. So the beginning inventory of week 2 is the ending inventory of week 1. So we have to start from week 2. The ending inventory should be computed from week 2, and it's all 0. So total ending inventory is 0, and therefore carrying cost is 0. So total cost for 8 weeks is 2100 plus 0 is 2100. So that's lot for lot. Okay, next is EOQ. So again we are continuing with problem 14. Number 2 is EOQ lot sizing. So for that we have to first find the average weekly requirement. So sum of requirements is 100 plus 250 and so on until 150, the last one. So that gives us 1500. So average requirement per week is, this is 1500 is the sum over 8 weeks. So we take 1500 divided by 8, which gives us 187.5. Don't round this because this is an average. Now given H is 80 cents per unit per week and S is $300, EOQ is 2 times weekly requirement of 187.5 times 300, okay, divided by 0.8. Okay. Remember the formula is, EOQ formula is 2ds over H. Now this D was annual demand and H was carrying cost for 1 year. Okay. But we can replace these two values for any time period we want. So since we are using weekly demand here, we need to use the carrying cost per week in the denominator, and so this is good. And this number, okay, so rounded comes to 375. So whenever there is a requirement, we have to place an order for 375, not the net requirement. Okay, so let's start here. So we have 100. So 100 minus 100 will give you 0. So there is a net requirement of 250. So we place an order for 375. So that's our EOQ lot sizing. So we have 375. Now 375 minus 250 will give you a balance of 125. Now we have a net requirement of 75. So once again we ordered 375. Now 375, take away the net requirement, we end up with 300. Okay. So 300 is sufficient for 150, so there is no net requirement. So we end up with 150 at the beginning of next week. And now we have a net requirement of 100. So we order 375. Now 375 minus 100 will give you 275, and once again 275 is good for 200, and that will leave us with 75. So we have 125 as the net requirement. So we order 375. Now 375 minus 125 will give you 250, and so there is no net requirement at that point. So this is our plan, MRP plan. Okay. So now we need to compute the cost. Okay, so we'll compute the cost per week. So setup cost per week, the average cost, okay, on the average. So EOQ, so this will be like how many setups. So we need the D over Q times S. Okay, so that will be 187.5. That's our weekly average demand divided by EOQ of 375 times 300. So this is our setup cost on the average. Okay, and that comes out to be 150. Okay. Now holding cost per week is Q over 2 times H per week. So we take 375 over 2 times 0.8 is per week. So that gives us 150 for a total of $300. Okay, so that's our EOQ working here, both setup cost per week and holding cost per week being the same. So total cost per week. But what we want is total cost for 8 weeks. So that is, you take $300, which is per week, times 8 weeks, will give you $2,400. Okay, you see that the lot for lot has a cost of $2,100, and by forcing an independent demand EOQ formula on dependent demand inventory, we end up having more cost than the lot for lot.